In this video, we're going to learn how to deploy our Node.js application to a live server. We're going to use Google Cloud Platform as the hosting provider, but the process is pretty much similar with other services like DigitalOcean or any other Linux hosting provider. Alright, so let's get started. Hey guys, it's Dockerizing here, and this is the part 13 of the series building a REST API with Node.js and MySQL. So if you are new here, make sure to subscribe and stay with the channel to follow the rest of the series. Some new stuff is very soon to be released, a new type of content. So stay with the channel to make this 2024 the best year for you as a developer. Alright, so let's get started. If you've been following this course from the beginning, we have covered so much regarding REST APIs with Node.js. We learned how to connect to database, how to implement CRUD, relationships between tables, and so much. So watch it. Please make it your handbook. It covers pretty much everything. So now we are in the last few parts of this series, and today we're going to learn a very important one, which is deployment. Well, it sounds scary. Well, it is, but now it has become so much easier. So today we're going to learn how to do it. Alright, so let's open up our project and let's start deploying our application. Alright, so here is what we're going to do in this deployment process. First, we're going to Dockerize our application. This makes our lives so much easier since we don't have to install anything other than Docker on the server. If we are not using Docker, we're going to have to install, for example, Node.js, MySQL, and SQLize CLI, and also some other process management tool like PM2 or something. And also we might end up having some, version problems and so many troubles. So Dockerizing your application is the way to go. Next, we're gonna set up a server on Google Cloud Platform. This is very important if you have no previous knowledge in setting up a server. The reason I chose GCP is that they offer $300 free credit to get you started. So it's very generous of Google, and the process is also very straightforward. And finally, we're going to push our code to the server using Git and get our application up and running. So these are the steps we're going to follow in this tutorial. So before Dockerizing our application, let me quickly show you the project overview. We are developing a REST API with Node.js, and we are using Express, and as the ORM we are using SQLize. So we are connecting to a MySQL database. We are developing a blogging system. So we have posts and we have users who create the post, and also we have comments that users can add on the post, and also we have images. Post authors can upload images to the post. So that's basically the functionality of this project. So we have a SQLize configuration here, and we have the controllers, and we have one helper file for image uploader, and we have middleware to check the token if the token is valid, and we create all the tables using migrations, and here are our models, and also we have some seeder files as well to generate the categories. Alright, so the functionality wise, this is a simple REST API. You don't have to worry about the functionality. We are focusing on deploying this application, so it works on pretty much any application, any type of application. Alright, so let's create a Docker file to start Dockerizing our application. Alright, so if you are new to Docker, I have another video to explain everything about Docker from the scratch. So you might want to check that out so that you will understand. So everything I define in this Dockerfile and Docker-compose file. So what's happening under the hood and what is the logic behind everything. You will understand everything if you watch that video. I will link it in the description down below. So otherwise you can follow along with me. Alright, so let's start populating our Docker file. First we need to get the image. In this case we need the image of node alpine. Just like this. And then we need to set the work directory. Let's put that as user source, then the app. Then we need to copy everything in our project folder to our work directory. We are skipping some files and folders like this idea directory and also this node module folder and some other files. So other than we're gonna copy everything inside this folder to our work directory. So first let's start copy our package.json file. And then we need to copy package log file as well. Alright, so then what we need to do is we're gonna copy other files as well, but before that let's add this command npm install. So as soon as we copy these two files, we're gonna run npm install command, so that all the dependencies will be installed. And then we need to install Sequelize CLI. So that is the one we are using to run all the migrations and everything. Just like this. So these two commands will everything, all the dependencies and Sequelize CLI. Alright, so let's start copying other files and folders. We need to copy this config folder. Just like this. Then the controllers. So if you are new to Node.js and this REST API concept, you might be wondering what these files and folders are and what's the logic behind everything we have created here in this project. So I strongly suggest you to follow along with me from the beginning of this series. It's pretty straightforward series. I teach you everything behind all the concepts, and it's very easy to follow along. We are building this project from the scratch. Then the migrations. And you just need to keep copying all the files and folders in the root directory of the project. And then the models folder. By the way, if you want more understanding on what we are doing here, you can watch my other tutorial regarding Dockerizing a Node.js application. By the way, if your project structure is something like you put all the source files inside a separate folder, and that folder is the one inside this project root directory, you just need to copy that folder. Since we don't have that kind of project structure, we just need to copy everything, every single file writing this copy command. So that's something to consider when you are start developing the project. Then we want to copy our env file. Then some other SQLize configuration file. We use this file to tell SQLize that since now we have an .env file to define all the database credentials and everything, we tell SQLize that don't look for your usual config.json file, instead use this .env file. Well, I think I should do a separate video on how to add an env file to the project rather than using SQLize default configuration file. By the way, it's been a while since we started this series. So if you started watching this series recently, I strongly suggest you to use TypeScript rather than JavaScript to develop this project. With TypeScript it will be so much easier, and you will be able to use new ES6 syntax as well. Alright, so we wrote commands to copy all the files in our project, all the necessary files. And next what we are going to do is we need to set the command to run this application. So let's add this cmd command, and here we want to run npm start. Alright, hit save. So the Docker file is complete. Well, next up we need to create a Docker compose file. Well, you know, in this application, to run this entire ecosystem, we need to run at least 2 Docker containers. One Docker container is for our application, and the other Docker container is for our database. So to run multiple Docker containers, we need to have a Docker compose file, so that all the containers can start on its own and continue running. Alright, so let's create a new file called docker-compose, and this is a YAML file. So I'm going to use this YML extension. Alright, so what we're gonna write here, the first property we're gonna add here is version. So basically we use version 3, that's the latest version, and then we need to define services. So in this case we need 2 services, which is the database service and also the application service. So as the first service, let me add a comment, db service, and let's name this service as db service, and let's name the container name, and I'm going to name that database container. And to create this container we need an image. The image is, since we are using a MySQL database, MySQL latest. So we are telling Docker that to create this container, pull an image of MySQL latest version, and let's add this restart property. We want to restart the database service just in case if it fails always. The next property is ports. So this is where we define all the ports that we want to run our service. So we need to define both external port, which is 3306, and also the internal port. And next, volumes. And this is also for the persistent storage. Let's say our database service, the Docker container stops or restarted or deleted. We don't want our data to be lost, right? So the persistent storage for keeping our data permanently on our local disk. So I'm going to use this db data directory on my project directory, and I have to use this exact path for our Docker container directory. That's where the data is kept from MySQL image. Alright, then we should define our environment variables, which is the database database name, database username, and password. So whenever we start this service, we want to assign those values so that our application can connect to the database using those credentials. So let's define this environment property. The first one is MySQL root user, and we can get these environment values from our env file we have defined here. So let's copy that, and I'm gonna use this dollar with curly braces syntax so that I can get that value straight from our env file, just like this. Then the MySQL root password. Then the database name. Well, I forgot to mention that in this env file, as you notice, the database host is this db service, which is the service name of our database service. Well, normally we keep our database host, if you are using MySQL server, we keep it like localhost. But in this case, since we are running Docker containers, we should keep the db host as the database service name. So in the Docker container file, copy this db service name and put it right here so that it can connect to the database service. If you keep the db host as localhost, the app will search for the local host of that particular container. So that's why we keep the db host as the db service. Alright, so that's it for our database service. Next, we want to define another service for our application. I'm gonna name that app, and I'm gonna name the container and I'm gonna name that app container. So we have database container and app container. And for this also we need to keep this restart property as always. And then I'm going to use this build property. So we want to tell Docker that the build context is current directory. Then we want to define the ports for our application. So for this we can use any port we want. I'm going to use port 3000 for our local machine and port 3000 for the Docker container port. So port 3000 will be used on our local machine. We can access the application using this, and the application will run inside the Docker container using port 3000. And then the depends on property. So this means we want to depend our application on we want to define this DB service here. It's because our application container will be useless without this database service. So we want to tell Docker that first start this DB service, then after that start this application service, because this application service depends on DB service. Alright, so this is pretty much it for our application container, and these two services are enough to run our application with all the ecosystem of our application. But I'm gonna define a third service here. Like I said, these two services are enough to run our application, but for the first time this application is running, the database is empty, right? We want to create these tables using these migrations. So we can simply connect to the container and run these migrations using a SQLize migrate command, but I want to automate that. So what I am going to do is I'm going to define a third service here, and as soon as this DB service is up and running, I want to run our third service to run migrations, so that the tables, if they don't exist, will be automatically created. So it's very easy for deploying. Alright, so let's define our third service, which is, I'm going to name that migration, and the container name I'm going to name that migrator, something like that. You can name it with whatever you want, and the build context is the current directory, and this should also depend on our database container. Oops, I have a typo here. Okay. Alright, and then I want to add a shell command, so that the shell command will run the migrations. I'm going to add this command property just like this, and well, I'm going to add the shell command here, but I have no knowledge of shell commands and everything. So what I did was I generated this shell command using ChatGPT. So let me paste it down here. Alright, so what this does is, the first part of this shell command is a loop. This NC means it's a netcat command, and it keeps trying until it can make a successful connection with our database service. So once the connection is successful, it runs this SQLize migrate command, the usual SQLize migrate command. So that's what happened in this shell command. So I generated this using ChatGPT. Pretty cool, right? Alright, so hit save. I think we are pretty much done with our Docker compose file. Let me double check these values are correct. Looks good. So why don't we open up the terminal and let's run this. Let me run docker compose up, hit enter, and it built in the image. Yes, it's still running. It's still not the migration are run. Yes, migrations are also successfully completed, as you can see. Let me open up the Docker desktop, and yes, we are running our application with all the services. Our database container is up and running, and our app container is also up and running. This migrator started and it did it part which is running migration, and it stopped. Alright, so let's open up our web browser and let's see if our application is accessible using the web browser. Yes, we can simply access our application using the web browser using this localhost and port 3000. Alright, cool. So what's next? So we successfully dockerized our application, and so the next part is hosting our application on a real server. So we are using GCP, Google Cloud Platform, as the hosting provider. So let's open up Google Cloud Platform, and let's create a project. So if you have no previous experience on GCP, don't worry. I'll walk you through step by step. So first of all, when you first sign up for GCP, you will see a screen like this. Then what you need to do is you need to create or select a project. So since I have a few existing projects, but I'm going to create a new project. So first you need to add a name for the project. So let me add a name. And hit create. So it takes some time to create the project. Alright, so project is created. Then you have to select the project, and then you are taken to this this screen where you can see a lot of configurations and options in this project. So next, what you need to do is, in your project you need to go to this section called compute engine, and in that sub menu we have a section called VM instances. So go to that, and here you can create a new VM in the sense virtual machine. So for this project you have to enable this compute engine API. So let's hit enable. It's taking some time to create it. Alright, so the API is enabled. Now you are taken to this page. Here you can create a new instance, and here you can see there are a lot of options that you can select for your virtual machine. So you can add a name. I'm just going to keep this like this, and you can select the region for your VM, the data center region, and also the zone. I'm going to keep these values as default, and then you can select the machine information, like what kind of performance, what kind of specs the machine should have for your case. So you can see the CPUs, the memory, and the platform, and everything. You can see all the details here. So in our case, we just need to run a small REST API with Docker. So we don't need much resources. So we don't need a high performance computer. We just need a day-to-day computing machine. So I'm just stick with this E2 instance type. So it's automatically selected for me, and there are some other configurations as well. So I'm just going to keep them as default. And for this firewall section, I'm going to tick these checkboxes, allow HTTP and HTTPS traffic. And alright, so let's hit create, and it takes some time to fully configure and get the server up and running. Alright, so the VM is created and it's already started and up and running. Alright, so now what? Now we need to access the server using SSH. Well, GCP provides a browser-based SSH client that you can simply click this button and it's open up in a new window. You can simply use the browser to SSH your server. So you need to sign in with your Google account, and you are taken to your server. So if you are running any Linux commands like this, so you are in the currently home of your user. Alright, so well, I'm not going to use this. Instead, I'm just going to use a local SSH client. So in this case, I'm going to use PuTTY. You can simply download PuTTY, and from their official website, and I already have downloaded and installed it, so I have that with me, so I'm not going to re-download it. So you can simply download it from their official website. So now we need to generate a SSH key so that we can add a key pair to our local machine and also to the server. So it will generate two keys, which is one is private key and one is public key. So the public key is for your server and private key is for your local machine. So these two keys are mathematically connected, so the server knows that this is a legitimate authenticated machine. Alright, so when you are installing PuTTY, another software called PuTTYgen will be installed. So you can simply search PuTTYgen and it will open up. So here you can generate a new SSH key by simply clicking this generate button, and now it's asking me to move your mouse pointer so that it can get some random inputs for generating the key. Alright, so the key is generated. Now as you can see, you can simply save the public key and private key, and also the public key is displayed here. So what I'm going to do is, in this key comment section, I'm going to enter my username which I want to create. So in this case, I'm going to add my username CodeRosam. And alright, so now you can save the public key, and make sure you save your key inside this default directory, which is C partition, and inside this users, and then the username, and inside the username .ssh directory. In my case, my username is just user. This should be your username in your local machine. So this is the default location for storing SSH keys in Windows. Alright, so inside here, and let's add some name, let's say GCP3. To identify it is public key, I'm going to add this pub extension. It's optional, and hit save. And also you can simply save the public private key, and it's asking me whether you are saving this private key without a passphrase. You can simply add a passphrase here, so you can make it more secure. I'm just going to keep it blank. GCP3. Alright, so the public key and private keys are saved. Now you should copy this public key, and let's add this to our VM in GCP. Alright, so go inside this VM and click this edit button. Alright, so now we are inside the edit section of our VM, and in this SSH keys section, you can see there are few other SSH keys added by Google by default. You can simply add a new item and paste down your SSH key you just created. Hit save. Alright, so we have successfully added our SSH key to our VM. Now we can simply open let's close this. Let's open PuTTY. So this is the default screen for PuTTY when you are opening it for the first time. Now what you need to do is simply copy the external IP address of your VM. You can simply copy it here and paste it down here in this hostname section, and add your username CodeRosum and at, so the hostname should be CodeRosum at then the IP address. Next what you need to do is inside this connection tree, inside this SSH section, expand that, and you can find this auth subsection, and inside that there is a section called credentials, and here there is a section called private key for authentication. You can simply click this button and browse for your private key here. Now you can simply click open and it will start the session, but I'm going to simply save this session so that I don't want to enter these credentials again. GCP tree, hit save. Alright, now you can simply click this open button and it will open up the SSH client, and now we are inside our server. Alright, simply enter some Linux commands. Alright, so now we are in the home directory of our user in our VM we just created. Alright, so next let's push our code to our repo so that we can clone it to our newly created server. So let me open up the project and commit these files and push it to our repo. Let me add a comment message like Dockerized. Alright, so now let's open up our server again and let's install Git on our server. Alright, so first let's update our package index, sudo apt update, and this will update our package index. And next let's type sudo apt install git. Hit yes, and this will install Git on our server. To make sure Git is installed, type git -- version, and it returns Git version. So Git is successfully installed. Alright, so what's next? Before cloning our project, let's install Docker on our server. To install Docker, let's simply update our package index again by simply typing sudo apt update. Alright, so I'm following this tutorial from DigitalOcean so that it has all the commands I need to install, all the packages related to Docker. I will add it in the description down below so that you can simply copy and paste and follow along with me. Well, there are some commands that I have no idea of, so you can simply follow the tutorial from this DigitalOcean website. Alright, so next I think we have another command to run, and looks like we are getting there. I think this will add the Docker repository. Alright, and hit yes, and that will install Docker, I guess. Alright, there are some commands that I have no idea of since I'm not much Linux expert. Keep going, and yes. Alright, so and this tells us Docker is up and running, so our installation is successful. Alright, so what's next? Now we have Docker and Git in place in our server. Now let's clone our project to our preferred directory. Let me clear this. Alright, so now we are in our home directory. I'm going to create a new folder by typing mkdir and the folder name is let's say blog. Now let's type ls and it shows me the newly created directory blog. Now let's go inside that folder by typing cd blog, and now we are inside our new folder. Alright, so now what? Now let's clone our repo here. So this is my repository. I'm gonna copy this URL and let's clone it to our server, to this directory. To do that, I'm gonna run git clone and paste down the URL I just copied. Hit enter and it will clone our repo. Alright, now what? Alright, so the project is ready. Let me just type this ls command and make sure we have cloned our project, and let's go inside our project directory, which is blog API, node.js and MySQL. And here we have all the files, but our env file is not there. We need to create it manually because we don't add env files to repos. So let's create sudo nano, then the env file name, and hit enter, and this will open up the nano editor here. Okay, let's open up our project and open up env file and copy these values and paste on our new env file. And to save this, hit Ctrl O and hit enter again, and it will save your env file. To make sure your env file is saved, type cat and then the file name. So our file has been updated. Now we can see all the content of our env file. Alright, so the env file is created. Now we are ready to run our application on our server. So to run our application, docker compose up, and it says permission denied. Why don't we just add sudo at the beginning of this sentence? And now it's pulling and creating all the images. Currently the database service is getting created and the images are getting built, and now the npm installation is going on. The packages are getting installed, and the CLI is getting installed. Alright, so the containers are created, and let's see if the migration are running. Alright, so the migrations are also have completed running. So we have a success response. Alright, so our services are up and running. So why don't we open up our browser and let's see if our services are up and running. So open up the browser and copy your external IP and paste it here. And since we are using port 3000, so we this should open our application. Well, it won't open because we need to manually open this port 3000. By default, only the port 22, which is SSH port, is open. We have to manually open this port 3000 in our VM. So this won't just work until we open our port. Alright, to do that we need to create a firewall rule. To create a firewall rule, I'm just gonna go to this search bar and I'm gonna search firewall policies. So it will suggest you some item and click it, and you will be redirected to firewall policies. So in this page there is a button called create firewall rule, and here you can define your firewall rule. First let's add a name, and it says add only lowercase letters and numbers and hyphens. So let me add block API traffic, something like this, and this should be unique. And you can add a description as well, and I'm going to turn on the logs, and the network and priority I'm gonna keep them as default, and then the direction of traffic, and it should be incoming. So to allow incoming traffic you should tick this ingress option. And other configurations like targets, so we need to specify which instances we want to target for this firewall rule. So I'm just going to add all the instances in the network. And for the IP range, since I want to allow any IP so that anyone can access our application, so for that I need to add this 4 zeros and 04. Add it like this, so it will allow all the IPs so that anyone can access our application. And I'm going to check this allow all button for protocols and ports, and we are good to go. Let's hit create button, and it will create the firewall rule for us. Alright, so the firewall rule is created. Let's try refreshing this page, and we are successfully accessing our application using our external IP and port 3000. Great. Alright, so now we can test our application using Postman. Let me open up Postman, and let's call some endpoints. Let's call this sign up endpoint. We need to update this host, which is currently the local host. We need to change this to our external IP of our GCP server. So let's copy this IP address and port, and here in our environment let's update the host just like this. So let's try calling this endpoint, the sign up endpoint. Let's see if this is working. Yes, we have a success response. The user has been successfully created. And let's try logging in. Okay, and yes, the authentication is successful, and we can successfully log in with that user, so which means that everything is working fine. So we have now successfully hosted our blog API in a real server, in a live server, so that anyone can access our application. So now we know how to deploy our Node.js application to an actual server. In the next video, I'm going to teach you how to automate this deployment process. So make sure to subscribe. Alright, so I hope you enjoyed the video. Hit the subscribe button if you haven't already, and I'll see you guys very soon in the next video.